This video is going to be on completing the square to write a quadratic equation in vertex form when it's given in standard form. So we have this quadratic equation, y equals x squared minus 8x plus 14, and we want to write it in vertex form. So we're going to complete the square to do that. Think of this as, here's your x squared. You have negative 8 x's. So we're going to split those in half. We're making a square out of this. So we're going to have 4 of them going this way, 1, 2, 3, 4. And those are just representing my x tiles. And then I've got 4 of them going this way, 1, 2, 3, 4. Okay, so I'm trying to make a square. If I had a square here, I would have 16 unit tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you get the idea. I don't have 16, though I would need 16 for a square. I only have 14. So you can see I've drawn 14 here. I'm missing 2 of them, and I need those 2 in order to make a square, to complete the square. So I'm just going to add 2 over here because I need to. And you might say, wait, you can't do that. That's changing the equation. You would be right. We also have to add 2 over here on the left-hand side. And you know that keeps our equation balanced. And we can algebraically, as long as we're adding to one side and we add to the other, we've kept the equation balanced and everything's valid. All right, so now the great thing is I have a square. I've added 2 more to that right side, and so I have 16. So now I have y plus 2 equals x squared minus 8x plus 16. And now I can complete the square. So this is a square with a side of, remember this length is x right here, and this is minus 4. I have 4 negative x tiles going this way, so minus 4 is that length. And this length over here is also x minus 4. 1, 2, 3, 4 of those. So x minus 4 times x minus 4 is that square that I made by adding 2 1 tiles in. Okay, so we have y plus 2 equals x squared minus 8x plus 16 is the same thing as x minus 4 quantity squared. You could check that by multiplying it out if you wanted. X minus 4 times x minus 4, and you would get x squared, x times x, distributing our x times negative 4 is minus 4x, minus another 4x, 4 times negative 4 is plus 16, and you can see that we have x squared minus 8x plus 16. So we haven't changed anything on the right hand side, we've just written it differently. And then we could subtract the 2 from each side if we wanted, and we would have y equals x minus 4 quantity squared minus 2. And hopefully you recognize this as vertex form. And that tells us that the vertex of our parabola is at 4, negative 2. And we know it's opening up because this x squared term is positive. So I can go over to 4, negative 2, and put my vertex. And I know it's opening up, and I kind of want one more point, right, in order to, that's supposed to be at 4, negative 2. We'll make that dot a little bigger. We want one more point and then a symmetric point so that we can make our parabola. So we could get the y-intercept. If we come up here and look at this and get the y-intercept, we know when we plug in 0 for x, the y value would be 14. That's off my graph, so I'm going to pick a different point. So I know the y-intercept, that's at 0, 14, but not very helpful if I want to graph it on this little square. So let's pick a point a little closer to our vertex. Let's do 3. Okay, if we put in 3 for x, then we get y equals 3 squared minus 8 times 3 plus 14, which would be 9 minus 24 plus 14, and the minus 24 plus 14 would be negative 10. So I have 9 minus 10, which is negative 1. So that tells us that when x is 3, y is negative 1. When x is 3, y is negative 1. So my parabola goes through the point 3, negative 1. And if I add that to my graph, I can actually plot that point. And since the parabola is symmetric about the x coordinate of the vertex, this line right here, we know it would also go through the point 5, -1. And now we have enough to draw the parabola because 3 points determine a parabola. And that is what it looks like. Okay, hopefully that made sense. Let's go ahead and do one more. Okay, so this is number 4 on the worksheet that I gave you. We have y equals x squared plus 2x minus 3. Again, think completing the square. To complete the square here, we have x squared and we have 2 x tiles. You're always going to split that in half. One's going to go here, one's going to go here because we're trying to make a square. Okay, so we have an x tile going this way, an x tile going this way, and we have our x squared. I'm only going to need 1 unit square to complete the square here. So I need 1. I need 1 positive one. Well, I have 3 negatives, and I want 1 positive. To get from 3 negatives to 1 positive, that's right, we need to add 4 to each side. So then we could rewrite our quadratic equation as y plus 4 equals x squared plus 2x plus 1. Notice x squared plus 2x plus 1, that's what we have represented in our square right here. And if I think of what this makes when I complete the square, this is x plus 1 on this side, and it's also x plus 1 on this side. So it's an x plus 1 by x plus 1 square. So I can write it that way, x plus 1 squared. Y plus 4 is equal to x plus 1 squared, or y is equal to x plus 1 squared minus 4. And now we have this in vertex form. We know that our vertex is at -1, -4. Go ahead and plot the vertex. -1, -4 is right here. And let's see if we can use our y-intercept for our second point. So go back to our original equation that's written in standard form because it's super easy to get the y-intercept from that. Just plug in 0 for x, and when you plug in 0 for x, you can see that the y-intercept would be -3. If you want me to walk that through for you, you'd have y equals, you plug in 0 for x, so 0 squared plus 2 times 0 minus 3, and you can see that y equals 3 when x equals 0. So when x is 0, y is 3. And we can plot that point when x is 0, we're on the y-axis, right? Here x is +1, here it's -1, and it's 0 right here on the y-axis. And when that happens, oops, I put 3, I'm sorry, I meant to say y is -3. If you caught me on that, good job. So when x is 0, y is -3. That was a -3, not a +3. So I'm going to put that right here. And we know by symmetry, again, here is our axis of symmetry along the x value of the vertex. So x equals -1, right, is the axis of symmetry. And so because the parabola is symmetric about that point, it's also going to go through this point right here, reflected across that at -2, -3. And now we can graph our parabola like this. And we knew it opened up as well because our x squared term was positive. And that's it. Hope you found it helpful.